So for today's lectures, we have natural logarithm function, len gx. In this one, the integration, as we can see here, the integration and here the derivation. The integration it will be integral g dash divided by g. It will be len gx plus the constant number c. The derivation divided by the function, the original function. And for the derivation, len gx, it will be g dash divided by gx. This one, the special form for the integration and derivation for the len gx, we should know how it is look like and we should memorize it. Because from this one and this one, we will be able to make the integration and the derivation for the function len. Let's see some properties of the natural logarithm. The possibility of converting the multiplication to addition. Len AB it will be equal len A plus len B. Convert division to subtraction. Len A divided by B it will be equal len A minus len B. Possibility to take the exponent outside the logarithm. Len A to the power n, this is the exponent, we can take it outside the logarithm, so it will be n len A. Let's discuss another important point, finding the derivative by using the logarithm. And we usually use this method if we have functions this complex to make that derivative, or we have multiple function product with each others. Let's see some example. The picture it will be more clear. Find the derivative of the following function. We have this example. Let's see the first one. This one. We will calculate the derivation by using the properties of len. So we will take the len for both sides of the equations. So it will be len y equal len this part, both sides. Notice that after using the properties of len, we derive both sides of the equations. After using the properties, we will convert the division to subtraction. So it will be len y equal len x plus 4 to the power 2 minus. And this one, the part we will take it outside. So notice that there is implicit derivation on the left side. So it will be y dash multiply 1 divided by y equal. We will take the derivation of the len. So this one, it will be the derivation of len, it will be 2 divided by x plus 4 minus, we keep the minus, and the derivative of this len x plus 3, it will be 4 divided by x plus 3. So we will multiply, we need the derivative, y dash, it will be equal this part multiplied by y. And y, what is y? Y equal this function. We will substitute and we will get the derivation of this function. Let's see another example. Y equal len 2x to the power 2 minus 2. In these examples, it will be just direct application of the special derivation of the len function. So it will be the derivative of len gx, it will be g dash divided by gx. It will be 1 divided by gx, so it will be 1 divided this function, multiply the derivative of this part of the function. So it will be 4x divided by 2x to the power 2 minus 2 after we calculate the derivative of this part. Same the situation here, same concept. it will be 1 divided by gx, this is the gx, multiply, we will take the derivative of this function. Next one, same also, it will be 1 divided by gx, this is the gx, it will be this function, we keep it as it is, multiply the derivative of the function. Here we have function multiply with each others. It will be difficult with the exponentials to make that derivative with the normal way. So we will use the logarithm, the properties of the logarithm, as we discussed it in the previous example. Same what we did here, we will do it here. We will take the len for both sides, and we will use the len properties. We will take the exponential outside, and later on we will take the y dash, multiply y by 1, and we will take the derivative of this one, of the len. It will be g dash by gx, and later on we will multiply by y, and we will substitute y value, this one. We keep this part as it is, and we put this y value, we put it this part, just normal substitution. Let's see another example for the integrals. Find the integral of the following function. We have these functions. Let's see how we solve it. We will multiply the function to be integrated by the value of a certain number, a numerator and denominator, in order to achieve the special form of the integration of the len function. This is the special form of the len function. An integral of g dash divided by g, it will be len gx plus the constant number c. So we will try to put the integral function in this form, the derivative function g dash divided by g, the original. So what is the derivative of this one? It will be 2. So it will be 2. We will multiply 2 in numerator and in denominators. If we multiply 2 divided by 2, we will multiply by 1. And we put it in the special form for the len function. So it will be the derivative, it will be len gx, this is the gx, the original function. And here after we make the simplification for the numbers, same concept what we will do here. What is the derivative of this one? 2x, so it will be g dash divided by gx. This is the original, and this is the derivative function. So it will be len x squared plus 4. Same situation here. The derivative here is 1, so it will be 1, the integral 1 divided by x, it will be len x. Same the concept here. The derivative of this one will be 3x to the power 2. So multiply the constant number, we will take it outside the integral. We can take it outside the integral, and we'll multiply 3 and divide, then the numerator and denominator will multiply also by 3. So it will be the original function, and here it will be the derivative of this original function. So it will be len x to the power 3 plus 3 plus constant number. Same concept, simple. It is very simple. Just for this function, just we need to know exactly what is the len function form for the integration and the form for the derivative, and put it in this form, and it will be easy to solve any function with natural logarithm. This is for the today lectures, and see you next time.